All right, good morning. I'm going to be giving you some information, so you're going to want to make sure that you write all of this down, different dates and things for the next exam and the final for seniors. So, all right, well, today I'm going to finish lesson 10.3. I thought I was done with it, but there's some things I have to teach. And so I'm going to finish that. And I will take questions before that. But if you want to write this down, you're going to have exam 10.1, 10.3 on Monday, May 17th during class. So rather than reporting to WebEx, you're going to take a test during class. Normally we take a test on Tuesdays in the morning, but we're going to take that exam during class. That's exam 10.1, 10.3 on Monday, May 17th during class. If you're a senior, gonna write this down, for period 2, your exam for seniors is Monday, May 24th during class. So on Monday, May 24th, as I'm teaching class, you're gonna be off on the testing site that we normally go to, taking the final. All right, and I might as well talk about the final while I'm on the subject. So just write this stuff down. All right, the final is 20% of your grade. So you can think of it like points. So you had 60 points for exams, 20 points for assignments, that adds up to 80, and there's 20 points that are still missing. So obviously, if you do really well on this, you could really raise your grade like a couple of grade levels. If you bomb this and you don't study for it, and you just wing it, and you decide, well, I'll just look at my book and I'll just search through the book and waste all this time and really not know what you're doing, and you bomb it, you could destroy your grade, and it could drop it from a C to an F. So, or a C to a D minus, a D definitely to an F. So you want to make sure that you don't blow this and make sure you study for it. And that's why I'm talking about it now. All right. There's 40 questions. And you're going to have 80 minutes to take it. So if you're a math person, you know that you have basically 2 minutes per problem. So 2 minutes per problem. And I would like to go over, I'm not going to give you a lot of hints right now, but I'm going to give you some major hints about the sections that we've covered and how many problems per each section. So make sure you write this down. So we did lesson 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, and 2.8. We also did 3.1, 3.2, 3.3, 3.4, 7.1, 7.2, 7.4, 7.5, and we're just finishing up on 10.1, 10.2, 10.3. So those are all the lessons we covered. And these are the number of problems you have per section. So in 2.1, there's 3 problems. 2.2, there's 2 problems, 2 problems, 2 problems, 1 problem, 2 problems, 2 problems, 1 problem. In 3.1, there's 2 problems, 3 problems, 3 problems. 3.4, there's 2 problems. 7.1 is 1 problem, 1 problem. I'm sorry, 7.1 is 2 problems, 1 problem for 7.2. 7.4 is 2 problems. 7.5 is 3 problems. 10.1 is 2 problems. 10.2 is 2 problems. And 10.3 is 3 problems. So that should add up to 40 problems. So let me just add it up really quick. So we have 5, 7, 9, 10. There's 15 problems there. You have 5, 10, 13, 15, 18 problems there, and 7 problems there. So there's your 40 problems. Now, there's some things I haven't said, like how are the problems weighted? For example, in 7.2, there's only 1 problem, but it's for 3 points. So I'm not giving any of that information until we see how it goes. I'm kind of upset with my pre-cal classes right now. People are absent, not turning in assignments, turning in things late, so on and so forth, and it's really bothering me. So why should I do anything if you're not? So we're going to see how things go. If you want more hints, need to be in class, need to turn in your assignments on time, don't turn in things late. Make sure you have your face on in the Math Wizard teams. Make sure you're working together in your Math Wizard teams. And I will give you more hints. If you are doing what I want, I will do what you want. So that's how that's going to go. Okay, are there any questions about anything that's scheduled or about the final? All right. So,
Wait, I had a quick question, Ms. Birch.
yeah.
So, would you think it'd be fine if we turn in our book after the final then, like the 24th or the 25th?
Yeah, I would not turn it in. I would not turn it in before the final. You need your book.
Yeah. Okay, thank you.
Yeah, basically, if you turn in your book early, you won't be, because see what I know what I would do. I just told you what's going to be on the final. So like every day now until the final, I would do 3 sections tonight, 4 sections. I would have it all outlined about how I'm going to study. Because if you try to study this the night before the test, you're not going to do well. In addition to that, if you say, well, I'm not going to study for it. I have my book, I have my notes. You don't have time for that. You only have 2 minutes per problem. So if you shuffle through the book trying to figure out how to do a problem, you're going to totally blow it. So you don't have time for any of that. You have to study. And you have to start studying now per day. How many sections are you going to do per day? How many problems are you going to work, per night? And if you don't start studying now, remember the finals were 20 points. So you want to try to get close to 20 points. That could really help the grade out a lot. And for those of you who like study the night before and you blow 20 points, like I said, it could drop the grade to an F. So you can't mess with this. It's 20 points. 20 points is 20 points. So you got to make sure that you're studying way ahead of time and that you know how to do the problems. Yeah, as far as the books go, you need the books until you take the final. So if you've already turned in your book, I don't know how you're going to study. It's crazy to turn in your math book when we're still using it. So don't turn in your math book. All right, so the first thing I want to do, does anybody want to ask me any questions about 10.3? I'm going to finish the lesson today. Any questions about 10.3 right now? All right, well, for those of you who haven't taken a picture of this or have this in front of you, you have to have this in front of you. If you take the exam 10.1 through 10.3 and you don't have this in front of you, I don't know how you're going to do on it. You have to have this in front of you. So you're going to use this extensively for that. Make sure you have it in front of you. Make sure you understand that what's the rule for an arithmetic sequence? What's the rule for a geometric sequence? What's the rule for the sum of an arithmetic series? What's the rule for the sum of a geometric series? And today I'm going to be talking about the sum of an infinite geometric series. You have to have this sheet of paper in front of you. If you don't have it in front of you, then I'm assuming you memorized all the formulas. And one of the reasons why I'm perturbed is because if you were in school with me, I wouldn't even allow you to use this. You have to memorize these. So if you were taking an exam in school, can't use your book. These have to be memorized. So it's like there's no excuse. You guys have your books you can use. You have this you can use. You have everything you can use. Get with it. All right. I ended on objective 4 in lesson 10.3. And I'm not going to do objective 5. It has to do with compound interest and banking and finding the value of an annuity. We're going to skip that. And I'm going to do objective 6. So objective 6 says use the formula for the sum of an infinite geometric series. So all these words mean something. Sum means add, infinite means forever, geometric means there's a common ratio, and series means the sum also. So let me give you the formula. It's S is equal to A sub 1 over 1 minus R. So it looks really simple, but it's not that simple because you're having to deal with a lot of fractions. So first of all, notice there's no subscript. So you're not finding the sum of the first 10 terms, the sum of the first 16 terms. You're finding the sum. Think about that. The sum of an infinite geometric series. You're finding the sum of something infinite. We've never done that before. So this right here is the sum. A sub 1 is the first term. And R is the common ratio. Now, there's some conditions for this. And the most important condition says this, that the absolute value of R has to be less than 1. In other words, the common ratio has to fall between -1 and 1. If the common ratio does not fit this condition, there is no sum. So if the absolute value of R is not that, which means greater than or equal to 1, the infinite geometric series doesn't exist. You can't do it. So let me just say this much. If you find an R that's like 7/2, just say it can't be done. The infinite geometric series can't exist. Why? It doesn't meet the condition. R has to be between -1 and 1. And that's what that absolute value means. So let's do a problem. All right, so they are asking us to find a sum, and they do say it's an infinite geometric series. So that's what this is down here at the bottom. Don't use the other formula. It's the sum of an infinite geometric series. So they're going to give you this 3/8 minus 3/16 plus 3/32 minus 3/64 plus ... And so the first thing we want to do, you guys, is we want to find R, because if it's not a common ratio, we can't do the problem. So this is going to be a little complicated, but we have worked with fractions. So you're going to take, remember how you take -3/16 and divide by the prior one, 3/8. So remember with division, you're going to change it to multiply and take the reciprocal. So the 3's cancel and you end up with -1/2. And I'm going to do one more to make sure I did it right. So I'm going to take +3/32 divided by -3/16. Change it to multiply and take the reciprocal, -16/3. That's not right. What did I do? Oh, I didn't write it right. I'm sorry. I'm like, what the heck? Sorry, this should be 3/32 times the reciprocal. So those 3's cancel. You get a 2 on the bottom, so it'd be -1/2. So your common ratio is -1/2. Now, does -1/2 fall between -1 and 1? So if -1/2 falls between -1 and 1, we can do this problem, does it?
Yes.
Yes, it does. Yes, it does. So we can use the formula. And if it didn't, you would just say, can't do it, doesn't exist, can't find, there is no infinite geometric series. But it does fall between -1 and 1. So let's write down the formula. S equals A sub 1 over 1 minus R. Seems harmless. So the first term is 3/8 divided by 1 minus the common ratio. So this would be 3/8. And remember, you need a common denominator, right? So we would multiply the 1 by 2/2. So we have 2/2 plus 1/2. Did you guys follow that or no? Last period had a lot of trouble with this. They couldn't remember about getting a common denominator. Are you guys okay or no?
I got it.
Yeah, if this was 1/6, you would multiply by 6/6. If it was 1/7, you multiply by 7/7. So what you have here is you have 3/8 divided by 3/2. Well, that's a complex fraction, right? So what you're going to do is lay the stack out flat. So you have 3/8 divided by 3/2. Change it to multiply and take the reciprocal. Cross cancel would be 1/4, wouldn't it? And that is the answer. That is the sum of that infinite geometric series. So let me make this perfectly clear what we did. If this went forever, if it followed this pattern forever, it's never going to be bigger than 1/4. And that's a crazy thing to wrap your head around. Like, what am I saying? I'm saying that if you took this out forever, it's getting closer and closer to 1/4. It's never going over it ever. Okay, so there's a lot of fractions here. We have worked with fractions a lot. I'm going to do another problem just to make sure we know how to do it. But does anybody want to ask me any questions about anything I did up here on the board? When you cancel the 3's, you get a 1, right? And when you cancel the 2 and the 8, you get a 4. So that's 1/4. Okay, let's do another one, okay? Yeah, don't let the fraction scare you away. because these are all going to be fractions. You can't run from the fractions in these problems. It's all going to be fractions. Okay, in your book on page 1074. So on page 1074, I'm going to do number 38. It's 1 plus a fourth plus 1/16 plus 1 over 64 plus dot, dot, dot. And they're asking us to find the sum of the infinite geometric series. So the first thing we want to do is find R. Because remember, if R isn't between -1 and 1, we can't do it. So why bother trying to do it if it doesn't exist? So you're going to take 1/4 divided by 1, working backwards. I'll do 2 of them. 1/16 divided by 1/4, and let's see what I get. So 1/4 times the reciprocal is just 1/4, and 1/16 times the reciprocal is 1/4. So does 1/4 fall between -1 and 1?
Yes.
Yes, it does. So we can find the sum. Is sum 1. So our first term is 1. Our common ratio is 1/4, and you're going to need a common denominator. So you have 1 over what? 4 minus 1 is 3/4. And if you remember what I said, one time I told you that 1 over a fraction is the reciprocal. So this is 1 divided by 3/4, which is 1 times 4/3, the reciprocal. So your sum is 4/3. All right, so the key to the infinite geometric series is make sure the common ratio falls between -1 and 1, and make sure you're dealing with fractions. So when you're adding or subtracting fractions, you need a common denominator. So let me just quiz you on this and see if you're okay. If you had 7 minus 2/3, what would you multiply the 7 by?
3.
3 over 3, not 3. It has to be 1. So 3 over 3 is 1. 5 over 5 is 1. And why do we want a 1 there? Because 7 times 1 is 7. 8 times 1 is 8. Anything times 1 is itself. Okay, so what if you had 2 minus 3/8? What are you going to multiply the 2 by?
8 over
8
8.
over 8.
Right, 8 over 8, which would be 16/8 minus 3/8 would be 13/8. So one more. What if you had 9 plus 3/5? What would you multiply the 9 by?
5 over 5.
Right. So that would be 45 over 5 plus 3/5 would be 48 over 5. So you're always going to have to do that right here. You're going to have to get a common denominator and subtract to get a fraction. All right, so this was finding the sum of an infinite geometric series. And I just have one more thing to show you. This is pretty cool, what I'm going to show you right now. It has to do with non-terminating repeating decimals. So watch this problem. Okay. 0.7 with the bar means 0.7777777. So they're going to say express, and that's non-terminating, goes forever, 0.7777777. You could have 0.23232323. You could have 0.751, 751, 751, 751. So if you have a non-terminating repeating decimal, you can write it as a fraction, believe it or not. So check this out. 0.7 is equal to 0.7777 forever. And what we can do is we can write a geometric sequence. Don't write this part down. Don't write this down. Watch this. Isn't this 0.7 plus 0.07 plus 0.007 plus 0.007? If I add that up, aren't I going to get that sequence? I mean, that number. So watch. We can write it like this. 7/10 plus 7/100 plus 7/1000 plus 7/10,000. 7/10 plus 7/100 plus 7/1000. So now our first term is 7/10, and we want to find the common ratio. Well, we could take 7/100 and divide by the previous term, and we get 7/100 times the reciprocal, which would be 7/10. And you could do another one if you want. Why does that not seem right? Oh, because it's not. Okay, hold on. You're not dividing by 1/10, you're dividing by 7/10. So it's 7/100 divided by 7/10. So it'd be 7/100 times the reciprocal. So the 7s cancel, the 0s cancel, and you get 1/10. So we can use, this falls between -1 and 1. So we can use our sum formula, a sub 1 over 1 minus r. So our first term is 7/10 divided by 1 minus 1/10. So we're going to multiply the 1 by 10/10. So we get 7/10 divided by 10/10 minus 1/10 is 7/10 over 9/10. Well, 7/10 divided by 9/10 is equal to 7/10 times the reciprocal. So guess what? We just found the fraction that matches 0.7 with the bar. And if you don't believe me, take your calculator and take 7 divided by 9. 7 divided by 9 is going to be 0.7777777 forever. So this is pretty cool that we can use the formula for an infinite geometric series to write an infinite non-terminating decimal as a fraction. And I have seen this problem on the SAT. So I have seen this. So it's a perfect way to use the infinite geometric series to write the decimal as a fraction. All right, I am done. I'll do one more of these. I'll do problem number 47. on that same page 1074. Do you guys see how I wrote the infinite geometric series? I showed you how I wrote them as decimals, then I changed the decimals to fractions. Let's do another one. So if I were you, I would try to do these problems in your notes. And then if you can do them in your notes, you should be able to do them in the assignment. So number 47, hold on a minute. Is 0.47 with the bar. So what that means is 0.47, 47, 47, 47 forever. And if we were to write the infinite geometric series, we would write 47 hundredths plus over there would be 47 thousandths. I'm sorry, 10 thousandths. So 0.47 plus 0.0047. See how I'm getting it? If I wrote it as a decimal, it's easier to see. So this is 47 hundredths. That's 47 ten thousandths. And this would be 47 over 1, 2, 3, 4, 5, 6 would be 1 million. So the first thing we want to do, we know that a sub 1 is 47 hundredths. We want to find the common ratio. So I'm going to take 47 ten thousandths divided by 47 hundredths, which would be 47 ten thousandths times the reciprocal. So the 47s cancel, those two zeros cancel, and you get 1 over 100. So that's good. That falls between -1 and 1. So if we use the sum formula for an infinite geometric series, a sub 1 is 47 hundredths divided by 1 minus 1 over 100. So you're going to multiply by 100 over 100 to get your common denominator. So this would be 47 hundredths divided by 99 hundredths. And that is 47 hundredths divided by 99 hundredths. So it would be 47 hundredths times the reciprocal. So your fraction is 47 over 99. And if you don't believe me, on your calculator, take 47 divided by 99, you're going to get 0.47, 0.47, 47, 47, 47, 47. So this is the fraction that's equivalent to this. All right, you guys, I am done with 10.3. What I'd like you to do is go into your Math Wizard teams. And I don't know who started this lesson and who hasn't. So you can either start, you have to work together though. So decide what problems you're going to work. And hopefully when I come in there, you're showing your face and you're talking through the problems. Remember that I'm willing to give you more hints about the final, but not if you're not doing what I want. All right, so we're going to see this week how that goes, if you get more hints for the final or not. All right, so I'll be taking attendance in the Math Wizard teams. We are working on lesson 10.3, and I will see you in your Math Wizard teams. Hold on just a second. Class is over at 12:10, so we're going to meet back here in case you need to ask me something at 12:05. So I'll see you back here in WebEx at 12:05. All right, you guys. All right, and we're back. So on problem number 13, I think I mentioned this to all of the groups, all the teams. Remember that when you put something on the calculator and it looks like that, that's scientific notation. So that means this is a very big number. If it was -11, it'd be a small number. So what this really means is this. So that's the calculator's way of writing scientific notation. So this means that you would have to move the decimal 11 times. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And like I said, if that was a -11, it would be a very small number. So anyhow, I'm not testing you on scientific notation right now. I don't like problem number 13, so you can just skip it. I also talked to the groups about a problem that looked like this. Now you remember that that really means -1 times 4/9. So there are 3 things you have to square here. You have to square the -1, the 4, and the 9. So I showed you a shortcut on how to do a negative. I said a negative to an even power is positive. A negative to an odd power is negative. So this would be a positive 4 squared, 9 squared. So this would be 16/81, correct?
Yes.
All right. Do you guys have any questions for me?
Yeah, so that whole section of 13, is there gonna be one like that in the test, or are you just gonna take that part out?
No, there'll be, I'm just throwing out problem number 13.
Okay.
So just number 13 I'm throwing out. But there will be problems like 9 through 16, yes.
Okay. Thank you, Ms. Birch.
And like I said, okay, so today we did good. Everybody showed their face. Every time I went into a group, people were working. There were lots of questions for me, and that's what I want. So this is a very good day. So you're on your way to getting some more tips about the test. And I'm specifically saying what types of problems you should study. So like in 10.3, I might say you need to study problem number 1 and problem number 9 and problem, you get what I'm saying? So those are the types of tips I'm going to give you. I'm going to tell you which problems to study, but I'm not doing anything until I see how this week goes. All right. In the meantime, like I said, you want to start studying for the final. You want to set up a schedule of how you're going to study, like each day, what are you going to study? Because this is a lot. It's a whole semester in one test. So you don't have time to be flipping through the books and flipping through things. I mean, you have to know how to work these problems. All right. All right. Hope you have a fabulous day. Have a great day. Okay. And I'll see you, on Wednesday? All right. Have a good day.